In this lecture, I want to introduce an algorithm that can be used to fairly divide n goods among two people. The name of the algorithm is adjusted winner. It was invented by Stephen Brams and Alan Taylor. And if you're interested and want to read more about this algorithm, I recommend these two books. The first is a research book on fair division written by Brams and Taylor. And the second is a popular book, The Win-Win Solution, also by Brams and Taylor. If you want to play around with the algorithm, check out this website, this first website here. The algorithm is implemented and you can play around with it and see how it works. And finally, many of these ideas have actually been put to good use, and a company was formed that uses adjusted winner and other related ideas to solve two-party disputes. So to read more about that, check out their website. Now, how about the algorithm? Well, rather than giving you an abstract definition of the algorithm, let's just run through an example. So this example will illustrate how the algorithm works in general. Suppose that we have two people, Ann and Bob, and they're dividing up three goods, A, B, and C. Now, the algorithm starts by giving each of Ann and Bob 100 points. And then Ann and Bob can divide up those 100 points among the items however they want, depending on their preferences. So for example, Ann assigns 5 points to A, 65 points to B, and 30 points to C. Bob assigns 4 to A, 46 to B, and 50 points to C. Now, in the first round of the algorithm, it's a winner-take-all approach. The person who assigned the most points is given that good. So Ann is given the goods A and B because she assigned more points than Bob did. And Bob is given the good C because he assigned 50 points while Ann only assigned 30 points to it. Now this initial allocation is not equitable because Ann receives a total of 70 points of her valuation, while Bob only receives a total of 50 points according to his valuation. So what we need to do next is go through a series of rounds of equitability adjustments. And the idea is that we want to transfer all or part of the goods from the person with the most points until both receive the same number of points. So since Ann has initially the most points, so initially she's better off, we're going to slowly transfer some of her points, some of the goods that she has, to Bob. So the first question is, which good should we transfer from Ann to Bob? Well, what we're going to do is we're going to look at the ratio of the initial point assignments. So we look at 5 over 4, so we look at 5 to 4. Since Ann has more points than Bob, we're going to look at the ratios of Ann to Bob. 5 over 4 is closer to 1 than 65 over 46. So we find the good whose ratio is closest to 1, and of course is greater than 1, because if the ratio is less than 1, that means that Bob already has that item. So we find the good whose ratio is closest to 1, in this case it's A, and we transfer either all or part of that from Ann to Bob until Ann and Bob have the same total number of points. So even if we transfer all of item A to Bob, the total points are not going to be equal. So transferring all of A to Bob gives Bob a total of 4 points, so for an overall total of 54, and Ann loses 5 points, so her total now is 65. So we need to continue the equitability adjustments, and we have to transfer now part of item B from Ann to Bob. So the question is, how much of item B should we transfer from Ann to Bob? Well, Ann has currently 65 points, and we're going to transfer a portion of that, say P. P is the portion that we're going to transfer of item B from Ann to Bob. So 65 times P is going to be the total number of points that Ann has after the transfer. That should be equal to the total number of points that Bob has. Well, how many points will Bob have after the transfer? Well, he's going to have 4 plus 54. because he has all of item A and all of item C, plus whatever portion of B he receives. So that's going to be 46 times 1 minus P, because if Anne gets the P portion of B, Bob is going to get the remaining 1 minus P portion of B. So this is equal to 100 minus 46P. So what we have to do is we have to solve the equation 65P equals 100 minus 46P. For P, that gives about 0.9. So about 90% of item B remains with Anne, and 10% is transferred to Bob. Once we do that, both Anne and Bob end up with 58.56 points. So they end up with the same number of points. So that's the algorithm. We end up, the distribution is Bob receives all of item A, all of item C, and about 10% of item B. So item B has to be divided. Now here's a few easy observations about the algorithm. First of all, for two-party disputes, proportionality and envy-freeness are equivalent. So proportionality means, in a two-party dispute, means that according to my own valuation, I feel as if I received more than 50% of the overall of my valuation of the overall set of goods. But if I feel like I've received more than 50%, then necessarily it has to seem, according to me, that my opponent received less than 50%. So for two-party disputes, proportionality and envy-freeness are actually equivalent. Note, adjusted winner only produces equitable allocations. In fact, that's how the algorithm is designed. The algorithm works until you achieve equitability. And finally, adjusted winner produces allocations at which at most one good is split. So it is true we have to assume that all of the goods are divisible, but for any instance of the algorithm, you're only ever going to divide at most one good. The problem is you won't know beforehand, before the people submit their preferences, which of the goods need to be divided. The general theorem here is just that adjusted winner is fair. We can prove that adjusted winner produces allocations that are Pareto efficient, equitable, that's easy, and envy-free with respect to the announced valuations. So Brams and Taylor proved that adjusted winner satisfies all of the desirable properties for fair allocations of goods.